We are in Chapter 7, Section 5. Today we're going to be solving quadratic equations by factoring. Up until today, we have been factoring quadratic equations. A quadratic equation just means when an x is squared. But today we're going to start solving them. We're going to start solving the equations, and that means we're going to figure out what the variable is. So quadratic equations are equations in the form of ax squared plus bx plus c. So a, b, and c are constants. That just means when a, b, and c are whole numbers, and a does not equal 0. All right, so this is, they took a quadratic equation and they factored it. And if you notice that what looks different now than other problems we've seen is that this time they've put an equal sign. So you can only solve an equation when there's an equal sign. If there's not an equal sign, you can't solve it. You can just factor it, you simplify it, but you can't solve it. So today we're going to be able to figure out what our x's represent. Now let's think about the zero factor law. So if you have any number times 0, you get 0, right? So if I multiply 3 times 0, that equals 0. If I multiply 0 times -5, that equals 0. So letter A, this represents a factor times a factor equals 0. So in other words, if this quantity equals 0, then it doesn't matter what this quantity is. 0 times anything is 0. So in order to figure out what x is, we want to know what x has to be to make this whole equation equal 0. So we don't want either this whole expression or this whole expression. If either one of those is equal to 0, then the whole equation will be true. So basically what we're going to do is say, okay, well, if this set of parentheses, what would it take for x to make this equal 0? Or the other expression could equal 0, either one of them. So basically you take what's in parentheses, you set it equal to 0, both sets of parentheses. Well, to solve for x, I'm going to subtract 4 from both sides. So do you agree with me? If x is equal to -4, doesn't -4 plus 4 equal 0? And it doesn't matter what this equals. If 0 times this expression, I would get 0 as an answer. So x could be -4. Well, this may not equal 0. Maybe this whole expression equals 0. Well, if this is 0, it doesn't matter what this would equal. I would get a product of 0 as well. So I'm going to take what's in here, set it equal to 0. Well, I want to get rid of -9, so I'm going to add 9 to both sides. So if x equaled 9, doesn't 9 minus 9 equal 0? So no matter what this equals, if I multiply it by 0, I get 0. So that means that x could be either -4 or 9 to make this equation true. And that's what we're going to do. We're always going to take what's in parentheses, set it equal to 0, and solve for x. So here we have x minus 5 equals 0. And we also take 2x minus 7 and set that equal to 0. So to get x by itself, I'm going to add 5 to both sides. Well, 0 plus 5 is 5, so 5 minus 5, 0. Doesn't matter what this quantity is, 0 times anything is 0. So x could be 5, but x could also be another number. So I want to solve for x. I'm going to add 7 to both sides. So I'd have 2x equals 7. To get x by itself, I can divide both sides by 2. And I can leave this improper fraction. So x could be equal to 5 or 7/2. And those are my two answers for each one of those equations. All right, so let's look at example 2. It says, solve the following equations by writing the equation in standard form with one side 0 and factor in the polynomial. So basically they want us to take this quadratic equation, and it's quadratic because our variable is squared, and they want us to set it equal to 0. And that's what it says, set each factor equal to 0. So the first thing I'm going to do, I want to have a 0 on the right side of the equal sign. So I'm going to get rid of this term. In other words, I'm going to subtract it from both sides of the equal sign. So 6x minus 6x is 0. Here I have 3x squared minus 6x. Now I can't combine these because they're unlike terms. Let me write that a little plainer. 3x squared minus 6x equals 0. Well, I want to simplify this first. So the first thing I notice is I can divide both of these terms by 3 and x. I'm going to pull a 3x out of both of these terms. So 3x squared divided by 3x is x. Negative 6x divided by 3 is minus 2. So basically, if this equaled 0, no matter what this quantity is, if this equals 0, 0 times anything equals 0. So basically, x could equal 0. If x were 0, this would be 3 times 0 times this quantity would equal 0. So one of my answers is x could be 0. The other one, what if this was a 2? Well, that's fine. But if this quantity also equals 0, my equation would be true. So the other thing I'm going to do is take what's inside the parentheses, add 2 to both sides to get x by itself. So there's 2 different answers for x. Whether x be 0 or 2, this equation would be correct. All right, let's look at example 2, letter B. So this whole equation is already set equal to 0. So like we did in our last couple of sections, we're going to think of 2 numbers. When I multiply them, I get positive 16, and when I add them, I get negative 8. Well, this tells us our signs are the same, and this tells us what our signs are. So the 2 numbers that multiply to give me 16 and add to give me negative 8 is negative 4. So these happen to be the same, right? So I don't have to take both of them, set them to equal to 0. I can just take one of them because they're equal to each other. So if x minus 4 equals 0, if I add 4 to both sides, that means x equals 4 to make this equation true. And if I plug this back in to this whole equation, 4 for x, I'm going to get a true statement. All right, letter C. So if you have something written like this, and if you're solving quadratic equations, you always want them to be equal to 0. Well, that means I have to subtract 24 from both sides to get that to go away. So now I'm going to bring down 4x squared minus 4x. These are unlike terms, so I can't add them or subtract them. Now my quadratic equation is equal to 0. Now I'm going to go, okay, well, I can divide every one of these terms by 4. So I'm going to pull out a 4. All right, so now I'm going to think, well, I need 2 numbers to multiply to give me negative 6 and add to give me negative 1. Well, the factors of 6 are 1 and 6. I can't get 1 from that. And 3 and 2. They're going to be different signs. The bigger sign is negative, so 3 is bigger than 2. So negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1, so I know that's right. Now, this 4 can never be equal to 0. So from now on, the rest of my problem, I get to ignore that 4. It's a 4. It can't be anything else, so I'm ignoring that. All I'm worried about now is what it would take to make either one of these parentheses 0. So I'm going to set the first one equal to 0 and solve for x. I'm going to set the second one equal to 0 and solve for x. So I'm going to add 3 to both sides. So x could be equal to 3. Here I'm going to subtract 2 from both sides, so x could also be equal to negative 2. So if x were negative 2 or 3, this equation would be correct. All right, letter E. I'm going to square x plus 5, just like it says, x plus 5 squared. So I'm going to FOIL this. X times x is x squared. X times 5 is 5x plus 5x plus 25 equals 36. All right, I'm going to combine my like terms. 5x and 5x is 10x. I want this quadratic equation to be equal to 0, so I'm going to subtract 36 from both sides. So I have x squared plus 10x minus 11 equals 0. Now I'm ready to solve for x because now my quadratic equation is set equal to 0. So is there two numbers when I can multiply them I get negative 11, but add them and I get 10? Well, the only two factors of 11 are 11 and 1. I can make them have different signs and the bigger sign positive. So let's see if 11 and negative 1 works. Well, 11 times negative 1 is negative 11. That's true. Positive 11 minus 1 is 10. So this is correct. Now I'm not finished. I still have to figure out what x could be. So I got to set my first expression equal to 0. My second one equal to 0. So I would subtract 11 from both sides. So x could be negative 11 or x could be 1. Those are my two answers. I have solved that quadratic equation. So all of these, these two have two different answers, and this one only has one, and the only reason it has one is because these matched. All right, example 3. The first thing I'm going to do is say, okay, can I factor anything out of this whole equation? And yes, I can divide all three of these terms by 2x. So 2x to the third power divided by 2x is x squared. Negative 4x squared divided by 2x is negative 2x. And negative 6x divided by 2x is negative 3. All right, I'm bringing my 2x down. I'm thinking of two numbers. If I multiply them, I get negative 3. When I add them, I get negative 2. This tells me the signs are different. This tells me the bigger of the two numbers is negative. The only factors of 3 are 3 and 1. The bigger number, 3, gets to be a negative. Is negative 3 times 1 negative 3? Yes. Does negative 3 plus 1 equal negative 2? Yes. All right, so earlier in front of the parentheses, we just had a 4. Well, we can never turn a 4 into 0, so we ignored it. Now this time, however, this variable, we have to set, since this is a variable, we have to set this also equal to 0. So if 2x is equal to 0, I would divide both sides by 2. So one answer is x would be equal to 0. If x were equal to 0, this whole equation would be true because I'd be multiplying 0 times something, and I'd get 0. All right, don't forget everything in the parentheses gets set equal to 0. So I'm going to add 3 to both sides. So x could also be 3, and x could be equal to negative 1. So this quadratic equation actually has 3 answers, negative 1, 0, or 3. All of those are true. All right, when you're solving quadratic equations by factoring, you're going to add or subtract terms as necessary so that 0 is on one side of the equation and the rest of the equation is in this form, ax squared. So this is a, b is always multiplied by x, and c is always your constant. You're going to factor completely. If there's any fractional coefficients, multiply each term by the least common. Okay, we won't worry about that. We're not going to get into that, I don't believe. All right, this note says factoring is the method to use. By factoring, you will find all solutions as shown in our previous examples. All right, so here are your problems, and I believe I've given you the answers. So if you want to try those on your own, do so. So I'm going to go ahead and work these out for you. Hopefully you've tried them on your own. So number 1, the first thing I notice is that I can pull out an x from both of these terms. So I'm going to pull out an x. Well, x squared divided by x is x. Negative 6x divided by x is negative 6. Now, what could x be to make this true? Well, x could be equal to 0 because if this were 0, it wouldn't matter what this is. 0 times anything is 0. So x could be 0. Also, whatever's in the equation, or excuse me, the parentheses, you said equal to 0. So I'm going to add 6 to both sides. So the answer is that x could be 0 or 6. Number 2. Now this isn't a perfect square, but we're gonna use trial and error to see if we can make if we can get an equation to multiply to give me 6. All right, let's just work this out. Let me see if I can think of 2 numbers. Let's try. The only factors of 6 are 1 and 6 and 2 and 3. Guys, we're going to, well, go ahead. I don't think you're going to have problems with this unless this is a perfect square. The other problems you'll have are when they're ones, but I'm going to go ahead and try working this out. But anyway, so the only factors of 6 are 1 and 6 and 2 and 3. Okay, so I'm going to try 1 and 6 first. And then the only factors of 1 are 1 and 1. So I'm trying to see if I can get to a sum of negative 1. Well, this is not going to work. So I'm not going to use 6 and 1. I'm going to use 2 and 3. All right, so I'm going to try 3x and 2x. Isn't 3x and 2x 6? Well, the only factors of 1 are 1 and 1. This tells me that my signs are different. So I'm going to try a positive and a negative. I don't think you'll have a problem like this, but I'm doing it anyway. All right, so 3x times 2x is 6x squared. 3x times 1 is negative 3x. 1 times 2x is 2x. And then, yes, this is what I started with, right? So anyway, this is the right factoring. Now the only reason I did this is to prove that this answer was right. So let's go back to this as our answer as it's factored. Now I'm going to use that to figure out what x can be. So I'm going to set both of these expressions equal to 0. So I'm going to bring it up here. So I'm going to let 3x plus 1 equal 0. And I'm going to let 2x minus 1 equal 0. All right, so I want to get x by itself. So the first thing I'm going to do here is subtract 1 from both sides. So I have 3x equals negative 1. And then I'm going to divide both sides by 3. So x could be negative 1/2. And then the second one, I'm going to add 1 to both sides. So I'd have 2x equals 1. I can divide both sides by 2. So x could be 1/2 or negative 1/3. You're just setting both of those equal to 0 and solving for x. All right, number 3. I'm running out of room here. So number 3 was x minus 2 squared minus 25 equals 0. Well, x minus 2 and x minus 2 minus 25. Well, if I FOIL this, I get x squared minus 4x plus 4 minus 25. These are like terms now. So I have negative 4x minus 21 equals 0. I'm thinking of two numbers. When I multiply, I get negative 21. When I add, I get negative 4. So that would be x minus 7 and x plus 3. I set both of those equal to 0. If I add 7, I get x equals 7. And here, if I subtract 3, I would get x could equal 7 or negative 3. Okay, that was number 3. And then number 4, I had x to the third minus 8x squared plus 16x. So the first thing I realize is I can divide all three terms by x. So I get x squared minus 8x plus 16. I want two numbers. When I multiply, I get positive 16. And when I add them, I get negative 8. This tells me the signs are the same. This tells me the sign of both numbers is negative. So it's negative 4, negative 4. All right, so since this x is by itself, I know that x could equal 0. And then both of these are the same, so I only need to set one of them equal to 0. Well, to get x by itself, I would add 4. So x could equal 4 or 0. And that's the answer. And that is the end. Oh no, I had some Hawks practice problems from this section. All right, so the first one, if you're solving quadratic equations, you have to have your equation set equal to 0. So this is straight from my Hawks. So the first thing I'm going to do is subtract 9 so I can set this equal to 0. So that part is already given to me, so I'd have to subtract 9. So Hawks would want me to type in this first. Now this is the difference of two perfect squares. This is a perfect square, that's a perfect square. So the square root of 25x squared is 5x. The square root of 9 is 3. And remember, when it's a difference of two perfect squares, one gets a plus and one gets a minus. So I've factored this quadratic. Now I have to solve it. Okay, so I'm going to set 5x plus 3 equal to 0. And I'm going to set 5x minus 3 equal to 0. So to get x by itself, I subtract 3 from both sides. So I get 5x equals negative 3. I'm going to do this one because I'm out of room, but I'm going to add 3 first to get x by itself. And then on both of them, I have to divide by 5 to get x by itself. If I divide them both by 5, that means x can equal negative 3/5 or positive 3/5. So that's a Hawks problem that I had. First thing you want to do is set it equal to 0. Set each of your parentheses equal to 0 and solve for x. This is another Hawks problem I had. All right, now this is only one term. This is a monomial. So this is in parentheses. There's nothing I can do to this except set this equal to 0 and set this equal to 0. So I'm going to set 9x equal to 0. And I'm going to set x plus 1 equal to 0. Well, to solve for x, I'm going to divide both sides by 9. So x is equal to 0. That's one of my answers. And then I took this parenthesis, set it equal to 0, subtract 1 from both sides. So x is also equal to negative 1. And those are my two answers. All right, continuing on with my Hawks practice. I got two more for my Hawks practice. I'm going to set both of these equations equal, I have two binomials, and I'm going to set both of them because they're both in parentheses. I'm going to set them equal to 0. So I have 9x plus 5. I'm going to set that equal to 0. I'm going to set x plus 5 equal to 0. To get x by itself, I subtract 5 from both sides. So I'd have 9x equals negative 5. Then I'm going to divide both sides by 9. So x is equal to negative 5/9. Also, I took this parenthesis, set it equal to 0. X is equal to negative 5. So my two answers are negative 5/9 and negative 5. Number 4, I want to set this quadratic equation equal to 0. So I'm going to subtract 9 from both sides. So I have 4x squared minus 9 equals 0. This is the difference of two perfect squares. Square root of 4x squared is 2x. Square root of 9 is 3. Because it's the difference of two squares. One gets a plus and one gets a minus. So I'm going to set both of these equations, or excuse me, both of these parentheses equal to 0. So I have 2x plus 3 equals 0. 2x minus 3 equals 0. I'm going to subtract 3 from both sides. So I have 2x equals negative 3. Then to get x by itself, I divide by 2. So x can be negative 3/2. That's my first answer. My second answer, I'm going to add 3 to both sides. So I have 2x equals positive 3. Then when I divide by 2, my other answer is positive 3/2.